Greetings. Today we're going to talk about density. And first of all, I want to show you something. I have made a little density column right here. And I want you to take a look at it. And yes, you can see there are 3 layers here, actually a 4th that's very thin. I have 3 different liquids, and the 3 liquids have different densities. That's why they're floating on top of each other. All right, so now I want to tell you a little bit more about density. Density is really the measure of how compact something is. If the particles are very spread apart, then it's not very dense. But if the particles are very, very close together, then it's a substance that is very dense. Now, I just want to give you a little idea of how you would work with density in the laboratory. In the lab, if you wanted to calculate the density of a substance, such as the density of water, I would, first of all, before I do that, I would take the graduated cylinder and I would mass it. And then once I mass and get the correct mass for the substance, I would then write that number down. Then I would go ahead, add the substance, which in this case is water, and I would again put it on the balance, and I would take this mass and subtract the mass of the empty cylinder from the mass of the cylinder and the water, and then I would get the actual mass of the water. Then at that point I could simply read my graduated cylinder, read the milliliters, and in this case it happens to be 52.1 milliliters. That way I could calculate the density, because density is mass over volume. So mass per unit volume. If I wanted to calculate the mass of a regular object, such as this, I would simply take a ruler, I would measure my regular object, and the way to calculate volume of something like a cube, I would take the length times the width times the height in centimeters, and I would have the volume of the cube, and then I would take the cube and mass it, and that would give me the grams over the volume. So I would divide the mass of the cube by the volume that I calculated, and that way I would be able to obtain the density. Okay, lastly, I'm going to talk about irregular objects, or if I wanted to get the density of these little beads, for example, these little beads of aluminum. First of all, I would take a certain amount of them, and I'm going to mass them here, and I would first of all zero my balance. I would take my pellets and I would mass them. Once I get the mass of the pellets, I would write that down. Of course, remember, you must subtract the mass of the dish that you're weighing them in. And then I would take my pellets and take a graduated cylinder with some water in it. For example, this one reads, I said 51.1, and I would add the pellets in there, not neglecting to lose this one. I would write the initial volume and the final volume. Then I would simply subtract the difference, and then I would know how much the volume increased by the pellets. That is how you determine density in the laboratory. For an irregular object, such as this, you would do the same. However, you have to be careful when you place this in the graduated cylinder that you don't drop it, because if you do, you run the risk of breaking the graduated cylinder. So those are 3 ways to calculate density: by direct measurement of the volume, by indirect measurement, by water displacement, okay, and again by water displacement, putting a substance inside. It is now time to solve some density problem. Let's go. A block of aluminum occupies a volume of 15.0 milliliters and weighs 40.5 grams. What is its density? Let's write down the variables first. What do we have? We have volume. Volume equals 15.0 milliliters. And the mass is equal to 40.5 grams. We know that density is equals to mass over volume. Therefore, we're going to plug in the mass, which is 40.5 grams, and we're going to divide it by 15.0 milliliters. 40.5 divided by 15.0 is equal to 2.70 grams per milliliters. And those are the units that we have. All right, let's try the next problem. The next problem says, what is the weight, or let's say the mass, I like this better, what is the weight of ethyl alcohol that exactly fills a 200 milliliter container? The density of the ethyl alcohol is 0.789. So what information do we have? What are we looking for? We're looking for mass. We don't know what that is, so we're going to write all the variables. We know that milliliters is volume, so we know that volume is equal to 200.0 milliliters. And we know that the density is equal to 0.789 grams per milliliters. Now, how do we go about solving for mass? Well, density is equal to mass over volume, as we said before. The first thing we need to do is to figure out how to solve for mass. Here's a simple way to do it. If I take density equals mass over volume, and I put a 1 here, all I have to do is cross multiply. I want a formula that stands in one line. So D times V, density times volume, equals mass times 1. So it'll be equal to mass. Now I can isolate the variable that I'm looking for. And the variable that I'm looking for is mass. So it's already isolated. So density times volume will be equal to my mass. So all I have to do is solve the problem now. Density is equals to 0.789 grams per milliliters times 200.0 milliliters. And I know that in this case, my milliliters will cancel out, like we said, diagonally, and I'm going to end up with grams. So let's punch that into the calculator. 0.789 grams per milliliters times 200.0 is equal to 157.8. 157.8, and my units are going to be grams. Now, we have to be careful here because there are 3 significant figures here, there are 4 significant figures here, and according to our significant figure rules, my answer is going to be to 3 significant digits, so 158 grams, and that is the mass of the ethyl alcohol. Let's try one more problem. What volume of silver metal will weigh exactly 2,500 grams? The density of the silver is 10.5 grams per centimeters cubed. So, again, I want to see what is given. So I have mass is given, and that is equal to 2,500.0 grams. And the density is equal to 0.5 grams per centimeters cubed. Well, how do I solve for volume now? Because that's what I'm looking for. Volume is equal to question mark. We don't know what that is. It's important that you write all of your variables so that you don't get lost doing the problem. So we know that density is equal to mass over volume. Now I'm going to do the same as I did before, and I will place a 1 here, cross multiply dV equals mass. Now, in this case, I want to solve for volume. So how do I do that? Well, I may have to get rid of density. So I'm going to do the same thing to both sides. Divide by density. Density leaves. Volume is equal to mass over density. My mass is 2,500.0 grams divided by the density, which is 10.5 grams per centimeters cubed. I pull in my trusted calculator. 2,500.0 divided by 10.5 grams, and that'll be equal to 238.1 if I round off. But I have 3 significant digits here, so I'm going to leave it at 3 significant digits. So that gives me 238